Okay, it's 10 past 10, I guess. It's time to start. Last time I gave that talk at the local JAG meeting. It took 2.5 hours, so let's go right into it. So you are probably wondering, so microservices, that's been a term you've probably heard a lot during the last couple of years, potentially over 10 years. If you are a bit older, you probably know that microservices, they used to be called somewhat differently in the past. So the term microservices emerged like 10 years ago, 14, or more or less 10 years ago. But earlier we had kind of similar concept called service-oriented architecture, SOA. And it turns out that if you dig deep, if you look at the core, they are more or less the same. The technologies vary, the local folklore varies, but at the end of the day, it's the same idea of decomposing big systems into smaller systems communicating over public APIs. The thing is, I think we still keep making the same mistakes over and over again. So my goal for today is to help you break the cycle and stop doing them. My name is Grzegorz Piwowarek. I do some blogging and consulting at forcomprehension.com. I'm also a founding engineer at Quesma, a new startup born in Poland. And I'm really proud of that because finally we have a company that originated in Poland that's doing tech stuff, and it's not just outsourcing work here. I'm also quite fresh Warsaw JAG Java user group leader. And if you want to follow me, you can find me on Twitter, X, and so on. By the way, if you have any questions, there's Slido for that. So the problem is that I teach a lot. I consult companies. I've written some of the microservices-based systems. I've made a lot of mistakes a long time ago. But I feel like we make the same ones all over again. So when I'm doing workshops or jumping into a company to do a consulting session, I can do a cookie cutter. I can take off some of the nodes they have from previous templates, just glue it together and sell it again, because there are so many same kinds of issues, at least when it comes to the tech stuff. The problem is that many companies jumped prematurely at the migration. That the pattern itself is pretty decent. It's not bad, but it feels like we had systems that we didn't have under control, and starting slicing them into smaller ones. And guess what? If you have a big ball of mud and you slice it into smaller ones, suddenly, the surface area gets bigger, which means it can stink a bit more. Our industry got really good at coming up with tools that compensate for poor design. So we started figuring out, okay, we did the split prematurely, but we started coming up with a lot of glue around that. But guess what? That if you are a company that sells a solution, that's great. But if you are the one buying it, you are probably overpaying for that. So let's focus on addressing the core issues. But before we go that, let's recall this guy. That guy in 1965 invented the null reference. So if it wasn't that guy, and he calls that, and he called it multiple times, his billion-dollar mistake. So it's comparable essentially to Oppenheimer and his work. So if that guy hadn't invented nulls, that's how our world could have potentially looked like. But it doesn't. But I think we are dealing here with another billion-dollar mistake, and that's microservices. But no. I told you a couple of minutes ago that I think this is quite a decent architectural pattern. The thing is, that small word in the name, that micro in the name, because that caused a lot of obsession. We've had service-oriented architecture, but now we are dealing with microservices. Does it mean we are dealing with microservices-oriented architecture? Is it the same? So how is microservice different from a service? What are the requirements? Where is the border between a service and microservice? So if there's a service and microservice, doesn't imply that we'll also have nano-services and so on? Probably not. So the thing is, we started talking about how small is micro. And how do we do that? People start asking, okay, tell me, 1,000 lines, 2,000 lines? 4,000, 30 lines? What's micro? How do you measure that? Maybe lines, that's a questionable metric. Maybe let's think about number of classes, the size of deployable, and so on and so on. But I can tell from the look on your faces that you feel that those are not good measurements. That's that's something that allows you to approximate more or less where's the border, but you feel like it won't give you a perfect result. One of the best measurements, one of the main guidelines, is that can you rewrite service in X time? I don't think it's the best one, but it's slightly better than focusing on the number of lines. However, that X time is very contextual. That changes a lot. So for one team, it might be 1 week, for other 2 weeks, and so on and so on. Before I answer that question, let me, because I know that you came here to hear the answer. Let me recall the core idea behind microservices. And the core idea was to enable scalability through independence and modularity. And when I say scalability, it doesn't necessarily mean number of requests per second and so on, throughput, but organizational scalability. So think about your classic big ball of mud. If you think that the red dots represent one feature, the green, blue ones, turquoise, whatever, the second one, the yellow one, the third ones. If you have a lot of coupling, if you don't think about boundaries, modules, and API separation, you are quite likely ending up with a lot of intertwined functionality mixed up together. So at the beginning, when they are dealing with there's one person dealing with 5 classes, they are probably very effective at that. But if your system grows into hundreds, suddenly all those features intertwine, you have 20, 30, 50 people working on that. Suddenly, making small changes is very hard. And sometimes refactoring is impossible, because suddenly you need to untie all of those arrows, and reattaching them means just a lot of work, because a small change can ripple through the whole system. And that's the point where you decide that, okay, it doesn't make sense. Let's not refactor that. Let's not spend half a year for that. Let's just carry on. Let's just provide business value. So the core idea behind microservices was to divide and conquer, keep things local and separate. So, if you're starting up a new greenfield system, one person working on one system, that's probably as efficient as it can get. No code reviews, just one person committing directly into the master branch. Obviously, there are disadvantages to that, but when it comes at pure throughput and avoiding bottlenecks, that's a perfect situation. When you add a second person into that, they will start clashing from time to time. So you might need code reviews. You might need to do merge requests. Resolve conflicts from time to time, and so on and so on. Let's add more people into the picture. And suddenly it becomes painful. Those people can't work together on one single code base. And adding more and more people doesn't really make the throughput of the business value delivery grow linearly as you add more people. So the core idea was to avoid coupling, keep things related close to each other, separate those modules, and let them communicate through well-defined public APIs with stable contracts. So we had a big system that was very hard to work with for 20, 30 people, but suddenly now you have 3 systems. So the whole point was to mimic the original idea. So instead of have the feeling working with one big system, you're working with 3 independent systems. You organize teams around that. So now it's not one big team, but probably 3 teams, with each team having different specialty. One team, they are owners of the red feature, the other is owner of the yellow feature, and they have independence when it comes to how they do it, when they deploy, how they version, and so on, as long as they stick to a public contract and evolve it in a backward compatible way. So that's the core idea that we often forget about. So those premature splits into many multiple services often end up not very well. So one of the horror stories I've been a part of, I was once asked to do an internal audit of one software as a service system. The VP of engineering had some idea that something was going wrong because they were not releasing very often. There were a lot of bugs, and the throughput was generally not good. But the team was reporting that they have like top-notch microservice, fine-grained architecture. I joined the team for a while and started observing what's going on. So they had like 68 services. Some of them were technical, but there were 6 people in the team. They produced 68 services, and my question was, what kind of traffic are you dealing with? How many customers are you serving? And the answer was 1. And I'm asking, but what's the 100,000, 10,000? No, 1. Do they pay? No, that's just a customer that's doing POC with us. So they invested quite a lot of time into splitting the architecture. I mean, building architecture from scratch this way. However, they did stick to old habits a lot, which made this releasable even harder than you'd imagine. The releases would happen simultaneously every couple of months. So that's to be avoided, but we'll get to that. So when you're avoiding coupling, unnecessary coupling, you want to avoid vendor locking your stuff. That's very tightly coupled to each other. Well, no pun intended. But if you vendor lock yourself or couple yourself too much, just call us. That's what we do as Quesma. So the thing is, you can have modularity. You can have some part of that value proposition without microservices. So you can start by modularizing your systems internally. At school, we are taught to modularize, separate private from public at a very low level. Fields, private, getters, public. But we also learned recently how to modularize the very high level. Well, microservices, yeah. Just slice everything by services and keep it service local. But there's something you can do also in between. So if you start modularizing your code base internally, keeping modules separate, separating private from public, that's where you start getting some of the benefits of modularity, but without paying all the extra cost of microservices. Obviously, you won't get all the benefits of microservices, but that's still worth a while. So what I've seen quite often is that new companies, they started from scratch building microservices. They know they have no customers, they have nothing. They already start thinking about, okay, there will be 13, 50, 60 microservices. They started scratching that out. However, a more natural journey should look more like you start with a monolith. You go into modular monolith and then to microservices when you actually need that. If you want to do some premature engineering, you can start with modular monolith. Well, I'm calling it premature, but I believe it's worth a while. But that's where you start with. There's not a lot of cost to pay, but you get quite a lot of benefits. And only when the time comes, then that's when you split. However, remember, the smaller the service, the more you maximize the benefits and downsides of microservice architecture. But those don't scale linearly. So there is a sweet spot. There is somewhere a sweet spot where when you start breaking services into smaller ones, and you keep doing this forever, because 1,000 becomes 500, 250, and so on, and up to the absurd point where a single function can be a separate service. So there is definitely a sweet spot where that there's a border that you don't want to cross. But the problem is that people come over and show this. Okay, so there are those big companies. They have architecture consisting of tens of thousands of services, and people say, look, but Netflix did it that way, and that worked. Why shouldn't we do the same? So first things first, Netflix has 2,000 engineers working on that system. Well, they had 2,000 before they started firing people. But what's more, they didn't start with that. Netflix is quite an old company, but they didn't start by coming up with. No one went to the basement for 2 weeks, came out and say, okay, that's what we are going to do. That's going to take us. We will need 20,000 microservices to make this work. they quite likely started with one big pile of mud that evolved over time into that. The system converged after many years into that what you can see right here. If you are starting from scratch and you start copying that, you are quite likely end up with a situation that resembles this, then something that perfectly matches your needs. What's more, quite happily, not that long time ago, Paul Baker from Netflix wrote an article. And he said that, yes, indeed, he confirmed that they have a lot of microservices. But what's more, if you look at the code base and many of those services, those microservices, they are bigger than many big ball of mud monoliths that you could see in other smaller companies. So that's the irony. You have 20,000 microservices, and some of those are bigger than monoliths in your company. So as you can see, microservices can end up being quite big. So if you hope to hear an answer that I can tell you, okay, what's the exact metric to look at, that metric that you cross and then you split, I can't give it to you. But I can tell you how to end up with an architecture that's going to be very close to optimal without spending too much time on learning techniques that give you optimal split. An optimal split can be obtained, for example, by playing with DDD and even sourcing. But I have 50 minutes to teach you that, and I don't have 50 minutes to teach you DDD. So I think the best idea is to figure out the optimal architecture, is to start thinking not about the size or the metric, but when to split. And it's not about figuring out the structure of splitting, but when you split into smaller pieces. And by splitting into smaller pieces, I don't mean splitting one into suddenly 100, but maybe into slicing it in half. And the answer is very quickly, when it starts hurting too much. So you have two developers working on 20,000 lines of code, and, well, everything looks fine. If you look at your DORA metrics, everything looks fine. They ship often, there are no bugs, they don't complain to HR a lot. Managers are happy with the output and throughput. Probably everything is okay, and probably you don't need to split, unless you have very, very specific requirements. But let's say you have suddenly those people ending up with constant clashes, constant merge requests, constant problems. That might be a sign that something is going wrong. Maybe it makes sense to split the system in half. Maybe there is a part of the system that needs to be released quite often, while the second part is quite brittle and you don't want to touch it. Okay, let's split it. And now you have 2, and not 100 suddenly. Maybe they maybe they acquired another company, and suddenly you have 30 new developers working on the system, and suddenly they all keep fighting and dealing with merge conflicts instead of, well, delivering work. Okay, let's split that. Okay, maybe there's a part of system that needs to be highly available all the time, but there's a part of system that has some internal in-memory state. Okay, that won't work together. Okay, let's split that. But again, let's split in half. Not from one monolith into suddenly 20,000 microservices. And so on and so on. The point is, you want to avoid going into the world of distributed systems as long as you can. I know it's fun to work and very satisfying to work on distributed systems, but from the maintenance point of view, replacing your Java method dispatch with over-the-network calls, that changes the world a lot. So if I go and deliver a workshop or consult someone, an indicator that something is going well for a company that's not yet mature is that usually they have one big monolith system in the center, maybe 2, 3, suddenly big services, and a bunch of smaller ones, satellites floating around. DHH called that majestic monolith, or the citadel pattern, where you have a couple of big ones in the center and small ones all around. That kind of suggests that the company is in this evolution phase. The architecture is not close to the final form, but it's evolving. So there's probably one big system. It's slowly getting sliced into smaller ones. But if you get into a startup that already have 100 microservices, they don't have customers, they have 5 people, that's usually an indication that something is likely going wrong, or they're probably wasting time on stuff that doesn't matter at that point in time, or they are optimizing, for Facebook-like success over the course of next couple of days, which is in most cases not happening. And if you did, that's another interesting snippets from Instagram engineering. So apparently the whole Instagram and Threads platform is running on monolith. And if Instagram can run on a big monolith, probably you can make it work as well. So don't worry if you don't split, because you are likely to make it even if you don't. But there's a bigger problem. You start splitting things in smaller pieces. But when you do that, if you want to benefit from all that value that microservices are trying to promise you, you need to forget about old habits. That's not a single system anymore. That's a distributed system. That's a collection of systems communicating together. So you need to forget about some habits. And let's recall that system I told you about a couple of minutes ago, that they tried to single version all the services. That's pretty common. So now you don't have one, you have 2 or more. But, well, there's probably one big monorepo. In GitHub, for example, where it's very easy to version everything at once. So all the services, they get the same version. This is very easy. From this, it's very easy to end up with synchronized deployments. So you don't deploy separately, you don't deploy individually, but just in case, you deploy everything at once. And that's problematic because, well, there's not much value in that. You want independence, you want to work on those small systems separately. But suddenly, if you need to synchronize, those multiple teams and, call them, hey, let's version it out and let's make a release. If you need to tell someone, okay, let's release this service first, then that, then followed by those 2, and then that, that's the value you get from that is very, very limited. So the same applies to all or nothing deployments. Like, you don't want to deploy everything at once. And the same, I asked the team about the same, and they told me, well, we can deploy separately. Of course we can, but we are not doing this, just in case. Imagine Netflix doing that, deploying just in case 20,000 microservices at once, or applying single versioning to all of that. There is clearly a point where it doesn't really scale. If you ask me, that point where it stops scaling is already at the count of microservices of 2. Another pretty common and clear pattern is that companies come up with a team structure where they heard that DevOps is desired. So come on, let's hire those DevOps people. Let's put them together in a separate team. And the worst that can happen is that they often get tasked with ensuring stability and security of the system. And guess what? If they are not working as part of the product teams and they are working separately, and they are punished for making a release that ended up with a potential failure, what's the biggest enemy of them? A change. Developers. Those evil bastards that are trying to change stuff. And if that stuff changes, it can break. And if the things break, they don't get the quarterly bonuses because, well, it's a responsibility of another team to do that. So that's a terrible setup, which ends up often in quite a lot of conflicts. If you read the original Google SRE book, there's the whole chapter dedicated to that, to the tribe war between ops and engineers and how they managed to solve it by introducing SRE. SRE as a methodology, not by another team, sitting next to developers. The kind of solution to the problem is to not create separate team. You still want to have people with those competencies, but you put them in the product teams and make them responsible for the product delivery. So if those people, if they are trying to block releases for no apparent reason, and if the team is not able to release fast, it's their problem. So the idea is to make releases as safe as possible, but also as often as possible. You don't want to stop them. So those people need to have responsibility as part of the product team to make sure that things get shipped. If things don't get shipped, that doesn't work. That's not good. Another thing, end-to-end acceptance tests of the whole system. That's something you need to let go at some point. If you have one service, you can probably end-to-end test it everything at once. If you have two services, you can probably do that as well. But as your system scales, to hundreds of services, and say hundreds of different functionalities, that becomes undoable. Again, think about Netflix trying to run their integration, acceptance test suite each time after something changes in their system of 220,000 microservices. That would probably run for a while. But let's say you want to do that. Imagine you want to run a test suite that runs for 24 hours, for example, or so, or even 1 hour. So there's a huge chance that during that 1 hour, one of those 20,000 microservices changes. So what do? If someone deploys it, well, the system is no longer in the same state as it was before. Okay, so let's go retest it again. Let's rerun it for an hour. Guess what? That won't scale very well. So companies sometimes figure out, okay, let's put a big pessimistic lock over the environment where you test. And guess what? That stops scaling very, very quickly, because suddenly you have, let's say, 10 or 15 changes queued to be tested on that environment. But guess what? Those things change all the time. Services change. So jobs that are only the task queue to be tested on the test environment that was frozen for the time of testing of different change will outdate very quickly. This stops working. So you need to let it go, the idea that you can test the whole system at once at a certain scale. Of course, obviously, you can test some parts of that at the same time. You can replace quite a lot of testing with contract tests and so on. But at some point, you need to let it go. You can't test everything at once at certain scale. However, remember the original microservices book. Sam Newman already said that that should be the main guideline for the whole presentation. If some of your practices make it really hard or impossible to deploy a service without touching anything else, you are quite likely to not experience the benefits of microservices, but unfortunately deal more with the downsides of microservices. So what I would like to talk about is another thing. There is this religious war. There are people that support monorepos, and some are supporting repos per service pattern. I've seen both work in practice well. However, I do have a preference, a very, very strong one. There is a problem with monorepo when you're starting out, and it's very easy to start out with that, because if you have one service, it's very easy to split it and have two services in one repo. It encourages sticking to old habits a lot. It's very easy to start versioning it at once, building it all at once, testing it all at once, releasing it all at once. What's more, making atomic commits to both services. It's two services that can be deployed independently. You can't make an atomic change to both, because that kind of induces the need for synchronous deployment. So, and that's something you don't really want. But guess what? It's very easy to make a commit. You make a pull request, you make a change in two directories, well, you commit, well, it's done. It's an atomic transactional write to both services. But now you need to deploy them all at once to make it work. So monorepos can work fine, but you need to invest a lot in extra tooling. Suddenly think, if you have 100 services in one repo, you need to figure out how to partially build them, how to tag them separately, how to release them separately, which becomes quite tedious. It's very easy if you have one service per repo. You can build your service template, you can put your Jenkins file in there, you can put it in GitHub repositories, you can put a tag over the whole repository, and so on. That's very easy. And if you make a change, well, you build the whole service and not just a subset of it. It's very easy. It requires a bit of extra, you need to generate more repositories. The downside of that is that, well, you might complain that, well, I used to have one convenient repository that I would just clone, but now I need to clone 50. But the thing is, modern IDEs make it very easy to work with different repositories. So if you take an IntelliJ IDEA, you can easily connect multiple source sets into one view. So you can still work with services put in different repositories, and in your tooling, in your tools, it will look like it's just a single monorepo. So you can have kind of both. But my preference is strongly for the service per repository, because I prefer to end up with situations where the setup doesn't makes it very hard to make a mistake. In monorepos, you need to consciously think about not doing something by accident. Another thing is, so you have 150 services. Congrats, you are now in the world of distributed systems. But now suddenly, all of those services need to be up and running at the same time. Need to be up and running at the same time to make it for the whole system to function. I think that's not very good for if you want to be highly available. So at some point, if the dispatch of the communication between services is not reliable, and network by definition is not reliable, although it's quite more reliable than it used to be a couple of 10 years ago. At least that's my impression. However, at some point, you need to stop thinking that you can have synchronous communication between all the services, because it will make it much worse for you from the point of view of high availability. You can have two types of communication. Often on microservices talks, you can hear that async is the one to go. But the truth is you can have both, but you need to understand the trade-offs. Obviously, the more async communication you have, the more resilient your system will be, but it will also display other qualities you might not like. In the world of distributed systems, when you have two nodes that need to communicate over a channel that can not deliver a message, it's not possible to provide both availability all the time and consistency all the time. Because if the communication channel disappears, there is no way those nodes can communicate and agree on the single version of truth. So if you ask one node about what's the value they are holding, they can either give you an incorrect answer, outdated answer, or not answer at all. So to be consistent or available. And that's also the trade-off between sync and async. If you want your answer to be as fresh as possible, you need synchronous communication. If you are okay with some slight delay and eventual consistency, async is the way to go. And that's good because if you have async communication, you don't need two services to be up and running at the same time to function. So in the normal sync communication, the way it looks like, you have two services. They will call HTTP GET. For example, classic HTTP is synchronous communication. You ask service 2 for an answer for something and you get it back. That's synchronous. But the service 2 needs to be up and running all the time. In async communication, you reverse that. It's service 2 that's communicating over events with the rest of the world. And service 1 is subscribing to those events and doing something with them locally. It can put in a database on some in-memory store, processes them somehow, creating some redundant view of the data. Redundancy is the cost of availability. So you keep redundant data locally that's getting updated as events are coming. This data can be slightly behind the source of truth, which is in service 2, but it's there all the time. If you kill service 2, you still keep serving data from service 1. This data can be outdated, but you know that when the service 2 comes back, it will send a new event and refresh this data, hence the eventual consistency. The data in the service 1 eventually converges to the state of service 2. Obviously, that requires quite a lot of work. We need to write infrastructure for that. So it doesn't always make sense to pay the cost for that. That's why I'm saying, don't split if you don't really need to. But you need to understand the difference between eventual consistency and accidental consistency, or permanent inconsistency guarantees, because that's something I keep saying all the time. And that's not the same thing. So imagine a classic example. You have a user service. you have a post, you have new user being created. So you have some HTTP post coming, the REST API, and you are saving data in a database, but at the same time, you want to publish the event that, oh, the new user is created. And that can be Kafka, RabbitMQ, whatever else, whatever. Because you wanted to implement the async communication. You wanted to tell other services there is a new user in the system. Let's do something about that. But here's the problem. It might look like this is an architecture supporting eventual consistency, but the devil is in the details. That's not eventual consistency, that's actually accidental consistency. Because there is no guarantee that this will always produce a correct, that you will both have an event in database and in your message broker, or any other second source. This is a dual write. This is not a transactional write to both places. You are just doing two independent operations. And now imagine a situation that's where you write something to database, you open a transaction, then you publish to Kafka. Kafka says, okay, I have your message, and it returns back an ACK to a client. Oh, but the connection drops, and you never receive an ACK. The Kafka client throws an exception, the transaction gets rolled back. So now, you've told the whole system that the new user was created, but there is no user in the source of truth, which was your database, and so on. So generally, if you don't do something extra, if you don't pay attention to that, you might end up with ghost events or data saved in a database, but not published over a broker. And that's not eventual consistency, that's accidental consistency with permanent inconsistency guarantees. And what usually I see is that there's a big transactional block over two separate independent writes. And that doesn't work. Spring can do a lot of magic, but it can't do that kind of magic, because that's physics. The problem is that you have two writes to two independent systems that don't support distributed transactions. Even if they did support distributed transactions, you would need something extra, like a transaction coordinator. Think about two-phase commit or tools like Atomicus. So how can you fix that? A very easy way is to stop doing two independent writes, but do just one. So you do a single write, the relational database, and then you have a separate process that picks up committed data from a database. So once the separate process notices that there is a change in the database, a new user appeared in the database, it pulls the database and then tries to send it to Kafka in a while loop until it does. And now you have a guarantees that when there is data in database, then you have a process that forever tries to send this message to Kafka. Eventually, it will work. However, again, for the same problem as said earlier, it might produce multiple copies of the same event. Because if there's a while loop that's trying to read something from a database, send it to Kafka, and the ACK gets dropped, okay, it seems like the operation failed. So it retries again until it succeeds. So this creates a need for consumers to be able to process multiple copies of the same message and to start thinking about that application and idempotency. Yes, that's a lot of work, but that's something you need to deal with in the world of distributed systems. If this is too much for you, don't split. So I'm not diving deeper into how to implement that. The two keywords you're looking for is transactional outbox pattern and CDC, and you'll be easily able to navigate and figure out what are the classic ways of solving that. Another thing I'd like to talk to you about is technology zoo. So when we started out with microservices, the big value proposition advertised was that now you can mix technologies. So now you don't longer need to have this one service in Java. You can have services in Java, PHP, Rust, Node.js, C#, and so on. And that sounds really good on paper, that you can mix technologies together. But in most companies that are not Netflix scale, that doesn't work really great. Because if you're 100 people having 20 services, each written in a different technology, suddenly forget about forget about people moving from teams to teams or some kind of dynamic reallocation, because when they switch from teams and they switch from Rust to PHP on the other way around, they won't be able to catch up pretty quickly. And working with 20 stacks is way harder than building your experience and your tooling for just a single stack. So the good rule of thumb would be to just don't throw in new tech unless there is a really good reason for that. Don't get me wrong, there can be many good reasons. And one of the good reasons for that is, for example, building competency in your area. So if you have all the services written in PHP, but now you decide to run service in Rust, maybe it's not because you want to benefit from mixing PHP and Rust, but maybe because you want to research new technology and see how it works in practice. That's also a very good reason. But then you consciously make a decision. Okay, I'm writing this new service in a weird technology that I don't know. It might not make sense tech or business-wise, but okay, we are spending this extra, we are willing to pay the cost because we want to learn the new technology. That's also okay. But most companies would surely benefit more from standardized stacks with occasional experiments and so on. That makes it way easier to work with. And if you've been in if you work on a bigger system that had multiple technologies blended in together, you probably know what I mean. And the last thing I'd like to bring up for today is don't repeat yourself abuse and the case of shared libraries. This always starts as a noble effort. So you have one big monolith. You start splitting that. Now you have 5 services in one monorepo. And suddenly you start noticing that patterns repeat. You have same DTOs in all the services. You have same frameworks, same libraries. You repeat auto-configurations from Spring. And it starts always as noble effort. Okay, don't repeat yourself. Let's move that into a shared component, like the bag with code. And so slowly, all of the stuff goes there. And that was a noble effort. So someone figures out, okay, let's make life of our colleagues easier, and let's add even more stuff to that. So, and that's how a core module is born. Libraries, utils, engine, common, or the mix of those. That's how a new module is born, and it starts growing. You start adding more library frameworks there, more versions, all the possible Jackson modules, Google Guava, Apache Commons, Spring, Quarkus, Helidon, because why not? That can be used, and so on. And you end up with dependency hell. And this is very important in the world of Spring, because as you know, Spring does quite a lot of magic by looking at what's at class path. Quite often, it doesn't have most newest versions in there. So if you bump one of your dependencies, and it transitively brings a newer version of that dependency, it will refresh all your dependency tree and include this new component in there. And this new component might not really work well with the auto-configuration of Spring. I'm not saying not to use Spring. I'm saying to avoid making it very hard for Spring to do its job well. So you have this one module. You have 100 services. You make a small change. Now you need to make change to all the services at once. Because, well, but at some point you figure out, okay, we've released a new version of the common module, but we've just bumped this small dependency, just bug fix. It can't change anything. Let's just not deploy 100 services, let's just deploy those 2. But then another small change comes. Okay, let's just change this small class. This impacts only 2 services, not 100. Let's deploy those 2. And after some time, you accumulate so many changes that those small trivial changes are not accumulate to one very big ones. And then you need to bump a service that didn't really change the version of the core library for a couple of months, and suddenly it explodes. But it's not a problem if it explodes. It's even worse if it stops working as it used to work, but silently, producing bad results. Jarek Ratajski has a great story on how they did some refactoring and they ended up with transactional annotations not working at all. That's not fun. And if you have a common module that everything is depending on, suddenly you kind of need to, it forces you to bump those versions everywhere. And if you bump it, a reasonable thing to do is to deploy. So it kind of brings us closer to the world where we have synchronous deployments and we deploy everything at once. Obviously, I don't mean you should avoid shared libraries, but don't treat them as bags of code. But if you decide to create a library that you share in your, within your whole system, probably treat it more like something you could have potentially open source. I mean, something that has very narrow focus and not just a big, big bag of code. And remember to version it and treat it as a normal library. Then it means that will mean usually that not all components depend on it, but just small subsets of the system that really actually needs that. And well, yeah, what's quite often common is if the split of microservices, let's say, wasn't optimal, you have business logic that repeats. So when the business logic sneaks into a common module, well, that's becoming really bad and very hard to manage. So avoid business logic at all costs in there. So another topic that pops up usually is what to do. I have REST APIs, I have this poor user, and I have 10 services calling that REST user's API and getting the same users. What do I do? And the most common attempt to solve that is to share contract by sharing Java classes. So the common module becomes a holder for many DTO classes, or someone comes up with libraries that are clients to certain REST APIs carrying Java classes as well, those DTOs. However, there's a big problem with that. Java classes are not special contract DSLs designed to describe deterministically REST API contracts. Java classes are interpreted by tools that you use for serialization. So if you have a Java class, it can be serialized, deserialized in so many different ways. And it all depends on how, for example, GeeCON is configured. And guess what? You will probably have different GeeCON configurations in different modules. So interpretation will vary from class to class. So someone at some point figures out, okay, we need to somehow figure out the way to make sure that those classes are serialized, deserialized the same way in all components. So people figure out that, okay, let's share interpretation as well and GeeCON configuration. But guess what? In the world of Spring, again, auto-configuration, class path scanning, dependency hell, it's very easy for this to break, to something change in the way you don't expect. And suddenly that's very bad. I've seen a situation in the past where a small change, like an addition of an extra GeeCON module, changed the serialization of Boolean values from is to get. So you wouldn't have a property in JSON called is something, but get something. And that broke quite a lot silently because components in other modules would deserialize the Boolean value and default to false always. Not fun. So the kind of bulletproof solution that I believe the best out there is, you build your own DTOs per each consumer. That requires quite a bit of boilerplate because, well, you need to have this user class in N services that are consuming their user's REST API. However, that gives you true independence. You fully control how you deserialize it, how you serialize that. You control how the layout of the class looks like. And you are not dependent on separate module that you would need to bump all the time when it changes. And that's for the cost of a bit of boilerplate. And that boilerplate is not that painful anymore with records. So I believe you pay the price of some extra boilerplate, but you end up with way more value, way more independence and safety guarantees thanks to that. So that's all I have you for today. Let's quickly repeat. So the main point for today was that you probably don't want to start with microservices. Microservices should be something that you keep in your mind, that you evolve into when you need to. But in most cases, when you start with microservices, that you are quite likely to experience more problems than value. You will always have time to do the split. So if you want to think about modules and boundaries, modularize your single monolith and then think about microservices. Congrats. You figure out you need to do a split. Now you're working with n-independent systems. Don't stop treating them as it's just one single system, as it used to be, because it's not. You are now prone to fallacies of distributed computing. The communication between services is not reliable. Start embracing eventual consistency, but keep in mind that eventual consistency is not the same as accidental consistency. You want your system to be able to converge into a consistent state over time and not converge into a system that's permanently inconsistent. Also, I believe you'll be much better if you don't throw new tech when you don't need it. Just spend some time, just wait until you really need it, then you throw in new tech. You will avoid many issues by avoiding technology zoo. So thank you very much. That's all I have for you for today. You can find the slides if you scan your QR code. You'll probably find more on Twitter. So thank you very much, and let's have a look at the questions. So the first question, don't you think that microservices are dead? It's too complicated and hard to test and integrate. People are returning to distributed monoliths. Microservices I don't think are dead. What's dead is starting with microservices and going premature and jumping onto the hype without really realizing that that's the pattern you need. I think that's dead, and I think that we as industry are converging into this state. Distributed monolith sounds like microservices done wrong. So I don't think people consciously want to do distributed monoliths. You don't want to do that. That's microservices done wrong. So I think you will see way more architectures that chose microservices because they needed that and not because they felt it's fun to start with. Because it's not fun. It gives you a lot of value, but the cost is high. So how about when to split? Maybe some kind of vertical approach. Split when some parts of API could be separated for better system reliability. I'm not sure if I understand the question right, but yes, when you do the split, you want to have vertical split. You want to separate functionalities from together. So, for example, if you're writing a system that's managing ordering movies, that's where you want to, let's say, one service will be responsible for ordering movies, second will be responsible for account management, for example. You don't want to do those splits horizontally. You don't want it's easy to split in architecture. If you have microservices, you have 100 services, but you see quite a lot of extra, very tight communication happening between couple services. That usually might be an indication that the split was horizontal and not vertical, that you didn't separate independent functionalities from each other, but you done the split horizontally, which induces quite a lot of artificial communication between those components. Okay, another one. About modular monolith versus repository per service. What about Git repo per module? No, I think actually it makes sense. If you have modular monolith, if this is just one single component, I think it's fine to keep everything in one single repo. At the end of the day, you are deploying this at once. So maybe let me clarify that. You want to have one repo per deployable, more or less. Split existing ugly code into microservices or write code from scratch and create services. Usually, when you start splitting code into microservices, if your code is totally ugly, if there is quite a lot of coupling, it's very hard to do that. So naturally, you will need to do some form of gardening before you're able to do that. So before you can split, you will need to establish some boundaries. So usually, there will be some extra effort needed to clean it up. Code that has a lot of spaghetti and is fully coupled, it would be very, very hard to split. And I would suggest to clean it up first a lot. if you can't really figure out how to clean up existing code, there is a pattern called strangler fig pattern, where you create a facade, you hide the ugly code behind it, you root everything from a facade, and you slowly strangle the original code, replacing it with a new one. So the keyword you're looking for is strangler fig pattern. Is better to start a new high availability application as a monolith? Yes, I think so, because you can achieve high availability in a different ways. So one of the easiest way to bring up the availability levels is to have multiple instances of the same one. So if you have one big monolith, the easiest way to do that, you can have a couple of instances of your monolith behind the load balancer. That's already high availability. That one often won't do the trick, but that's the very easy starting point. So you don't need microservices for high availability, you need multiple instances. What about not using Spring? Maybe updates of common module would be much safer. Oh, the thing is, if you have microservices and dependence, well, you probably don't want to influence decisions of other teams. So the reality is that it would be easier without Spring, but you're quite likely will need to touch it anyway because other teams like it. Should we include microservices in the planning of the new project, or rather start with monolith and then split it later? Definitely start with monolith. You will always have time to split it. If you are thinking about, if you really feel that you will need that, start modularizing it. Make sure that this vertical structure is in there, so that when the time comes to split, you split and not start cleaning things up. So if you have multiple vertical modules at the same time, in the same system, in the same single service. When it's properly modularized with separate modules, what you do, you can copy and paste the same module, remove module A from the one, remove module B from the second, replace the communication between those high-level public APIs with HTTP clients, and here you go. That's all. Okay, guys, we don't have time. Okay, thank you.